This is a Math 3 summary video for the lesson titled Viable, Valid, and Verified. This lesson is a Solidify Understanding task. The purpose of this lesson is for students to determine the validity of an argument and to critique the reasoning of others. Students will examine various proofs and determine if the proof progresses logically and if there are any gaps or missing pieces in the proof. If there is something lacking in the work, students will determine how the proof can be improved. In Math 2, you discussed the ways of knowing, which describe 4 common ways that people come to know something. Our work in this lesson is related to the last of the 4 ways of knowing, making an argument based on previously proven statements and logical ways of reasoning. For each problem in this lesson, there are several potential attempts to provide logical proof by students. Your job is to decide if the argument makes sense, if statements flow and connect in a logical way, and if the argument is based on logic or some other type of reasoning. In this video, we're going to look at vertical angles proof. Vertical angles are formed when 2 lines intersect. Vertical angles share a vertex point, and they are opposite from each other. This diagram shows 2 pairs of vertical angles. Angle AEB and angle CED are vertical angles. Angle BEC and angle DEA are also vertical angles. For this proof, we are given that lines AC and BD intersect at intersection point E. We need to prove that vertical angles AEB and CED are congruent. Student A decided to write a 2-column proof. First, they started by listing what was given, which is an excellent way to start. Then they list that angles BEC and AED are congruent. This statement and justification lacks logical reasoning. Even if it is true that these 2 angles are congruent, we'd need a previously proven statement or logical reasoning. What they listed for the statement is that the 2 angles are congruent, and what they listed for the justification is that the 2 angles are congruent. This is not a logical justification. The other problem with this statement is that it is not necessary. We do not need to figure out if these 2 angles are congruent to prove that angle AEB and angle CED are congruent. The next 2 statements are true. They are true because the angles form a linear pair, which should be referenced in the justification. But the bigger issue with these 2 statements is that they do not support a logical progression for the entire proof. The statements that are chosen for the proof need to build on one another to reach the desired conclusion. And now finally, we reach the last line of the proof. The student correctly listed the statement they were trying to prove as the last statement, but the justification is not appropriate. Justifications need to provide a specific and logical reason for each statement. Since this proof does not show a logical progression of reasoning based on previously proven statements, this proof is not valid. Student B approached this problem differently. Not only did they write a paragraph proof, but they used definitions of rotation. They remembered that rotations are rigid motion transformations, and that if you rotate a figure so that it coincides with another, that means the figures are congruent. Their work supports a logical progression throughout the proof. They start by stating correctly that when you rotate a line 180 degrees about a point, that it will land on itself. They then logically conclude that if you rotate the lines, the angles created by the intersection of the lines will also rotate 180 degrees, making the vertical angles land on top of each other when rotated 180 degrees. They conclude their proof by referencing that when you perform a rotation and one figure lands on or coincides with another figure, the figures are congruent. This proof is valid. Student C's proof is not valid. Their reasoning is stating that since they look congruent, they must be congruent. For proof, we need a logical argument, Saying that something must be true because it looks like it should be true is not an example of logical reasoning. Student D started by stating what was given. Then they used the definition of linear pair. This was a good choice because they had two angles that made a straight line, meaning that the sum of the measures of the angles is 180 degrees. And they could use this relationship to write an equation. In their third step, they used the same logic to write a second equation that shows two angles with a sum equal to 180. Since they have two equations that are equal to 180 degrees, the two equations must be equal to each other. Now that the equations are set equal to each other, we can see that both sides of the equation use the measure of angle BEC. Student D used this to subtract the measure of angle BEC from both sides of the equation. The subtraction property of equality tells us if you subtract the same value on both sides of the equations remain equal. This left us with a statement proving that the two angles we are interested in have equal measures. We are, however, being asked to prove that two angles are congruent, not that they have equal measures. So in the last step, this student uses the definition of congruence to write their final statement, claiming that since the measure of the angles are equal, the two angles must be congruent. Student D's two-column proof is valid. It's different from student B's valid proof because instead of using the definition of rotation, this student uses the definitions of a linear pair and algebraic properties of equality. Even though both students took a different path for proving that vertical angles are congruent, both methods demonstrate how to make an argument based on previously proven statements and logical ways of reasoning. That's it for this video. Thank you for watching.